At this point in our study of quadratic equations, we've learned two methods: solutions by factoring and solutions by the square root property. Those two methods are fast and efficient, but they don't apply to every quadratic equation. For example, not all quadratics are factorable. Some are prime. And not every quadratic equation can be solved by the square root property. So we have the need for methods that are reliable and always work. And we have two of those methods. Section 2.2.3, we will learn how to solve by completing the square. This method will be dependent on our ability to do the square root property. So to solve by completing the square, we're going to form what's called a perfect square trinomial. Let me take a minute to remind you what this looks like. A perfect square trinomial takes the form x squared plus 2bx plus b squared. I know that looks strange, but the 2b and the b squared are constants. This factors as x plus b times x plus b, or x plus b squared. Or another form I may see a perfect square trinomial may have this pattern: x minus b quantity squared is its factorization. So don't be intimidated by those formulas. When we complete the square, we are guaranteed to form a perfect square trinomial, and it's going to factor the same way every time. So keep these patterns in mind. Again, these are called perfect square trinomials because they are trinomials and they factor as a perfect square. So let's see how this applies to the process of completing the square. When I solve by completing the square, my first goal is to kick out the constant. You're going to see that's going to be the term that is preventing us from factoring. So step one, we're going to collect the quadratic, that's a fancy word for the x squared term, and the linear term. Linear is fancy for the x term on one side, and the constant, that's the number, on the other side. Collect the x squared and x term on one side and move the constant to the other. Or you can think of it, kick the constant out. Then in step two, this is the heart of the method. We're going to complete the square. So we're going to rewrite our trinomial so that it matches one of the patterns of the perfect square trinomials. So to find this constant that's going to go with our quadratic and linear terms, we're going to go through the same process every time. Step two, divide the linear terms coefficient by 2 and square the result. Okay, this is what I'm going to call the magic number. So what in the world is going on? Well, taking a peek at our perfect square trinomials written at the top of our notes, we're going to have the quadratic and the linear term together on one side. Our goal is to find the constant that will make that pattern the perfect square trinomial. So we're going to take the linear coefficient, which in this case is 2b, we're going to divide it by 2 so that we can get rid of that 2, and then square the result. Well, notice if I take 2b and divide it by 2, I get b, and when I square b, I get b squared. So what we're actually doing there is determining the constant that makes it a perfect square trinomial or completes the square. Once I find this magic number, I'm going to add this number to both sides. Okay, and we will have completed the square. Step 3, we will factor the perfect square trinomial that we form, PST, perfect square trinomial, completely. And simplify the constants. Once we have it factored completely and our constants are simplified, we are home free. Step 4, solve using the square root property. And you already know how to do that. That's one of our simpler methods. Okay, we'll end up with 2 solutions. So what do you suppose step 5 is going to be? I hope that you always know your last step for any math problem is to check. We can check by substitution. Okay, so let's give this method a try. Solve by completing the square. So example 3, solve by completing the square. So we have a quadratic equation. Notice the x squared. And in this case, we already have the quadratic and linear terms together on one side and the constant on the other. So step 1 is done. Step 2, I'm going to find the magic number. So to do this, I'm going to follow the same process every time. I'm just going to do some little side work here. I'm going to take the linear coefficient, just the coefficient, -4. So I'm picking up this number right here. I'm going to divide it by 2 and square the result. Well, -4 divided by 2 is -2, and when I square that, I get +4. So +4 is the magic number that completes the square. So I'm going to add that number to both sides. We have x squared minus 4x. We're going to add our magic number that completes the square. And we're going to do that on this side as well. Whatever we do to one side, we have to do to the other side to keep a balanced equation. Okay, now the left side is automatically a perfect square trinomial. So I'm not going to think too hard about the factoring. I know you've been thinking hard about factoring, but in this case, we know it's a perfect square trinomial, so it's going to factor as something squared. Okay, this term right here is always going to be the square root of that first term, which in our case will be x. And this term will always be the square root of the constant we found. It's going to be 2. And our sign in our binomial will be the same as this sign right here. Okay, now notice in our factor we have -2. That's always going to be familiar because we will have seen that number over here. So we factored the perfect square trinomial. If we were to write it out longhand, it would be x minus 2 times x minus 2. But again, when you complete the square, you always know it's going to be the square of some binomial. So think about factoring it with a pattern and don't think too hard as far as trial and error goes. So I went ahead and added constants on the right side. -3 plus 4 gives us 1. Notice we have the quadratic or x squared part isolated on the left and nothing but a constant on the right. That means we can finish with our square root property. So I'm going to take the square root of both sides, remembering the plus or minus on the right. And we have x minus 2 on the left equals plus or minus 1. We've got one more step to do to solve for x, and that is add 2 to both sides. And I'm going to sneak that 2 in front of the plus or minus. And I don't want to leave it like that. Those numbers are compatible. So let's separate them. One answer is 2 minus 1. The other answer is 2 plus 1. And we can certainly evaluate those. 2 minus 1 is 1, and 2 plus 1 is 3. So we have 2 solutions for our original quadratic equation. So we solved that by completing the square, but I do want to point out this one could also be solved by factoring. So let me go back to the beginning of the problem, and I'm going to set it equal to 0, so I'm going to add 3 to both sides. Notice we could factor this one as x minus 3 times x minus 1. We could set each factor equal to 0 and solve for x, and we would get the same 2 answers, okay? So on this particular quadratic equation, we could solve it by factoring, and we happen to solve it by completing the square. But hopefully you see that we got the same answer either way. Now let's try the next example. Example B, solve by completing the square. So when we solve by completing the square, we have to have our quadratic and our linear terms together on one side and nothing but a constant left over on the other side, right? Then we're going to do our process of completing the square. We're going to take our linear terms coefficient, divide by 2, and square. That's the same process every time. So we end up with 5 squared, or 25. 25 is the magic number that completes the square. So I'm going to go ahead and add that to both sides. Don't forget to add it to the right side. And then our trinomial that we formed is a perfect square trinomial. So it should factor as the square of some binomial. Remember, the first term is going to be the square root of this term, which in our case will be x. The second term in our binomial is the square root of our constant 25, and our sign matches that first sign. So we have factored the perfect square trinomial. Combining constants on the right side, we end up with 45. So at this point, the completing the square process is done. I finish with the square root method. So I'm going to take the square root of both sides, remembering plus or minus. The square cancels on the left. Let's think of 45 as 9 times 5. So we can evaluate the square root there, 3 square root of 5. We will finish by subtracting 5 from both sides. I'm going to go ahead and write this down so you see what happens. X is isolated, and we have x equals, I'm going to put the negative 5 in front, and plus or minus 3 square root of 5 second. So we have two irrational solutions, negative 5 minus 3 square root of 5, and negative 5 plus 3 square root of 5. Okay, and I want to go ahead and check this one by substitution with my calculator, and I'm going to use the method of storing an answer under a variable to make it really easy to plug in. So first I'm going to enter negative 5 minus 3 square root of 5. I'm going to use my right arrow key to get out of that radical, and I'm going to store it under letter A. Okay, now while I'm here, I'm going to do a shortcut. I'm going to type second, enter, and that recalls what I just typed in, and then I'm just going to edit a little bit. I'm going to change the minus to a plus, and I'm going to change the A to alpha B. So I have both of my two answers stored, one under A and one under B. So going back to our original equation, we can plug in A for x. We have A squared from the left side, and from the right side, negative 10 alpha A plus 20, and we have a balanced equation. So we're confident that our first solution is correct. I'm going to do the same thing with B. I'm going to evaluate B squared, and then negative 10 alpha B plus 20, and hope for the best, and we do have a balanced equation on both sides. So both of our solutions are correct, and we can be confident that we have the right answer. Okay, one more example for completing the square. Remember, our goal is to rewrite it so that the left side's a perfect square trinomial, which means our constant has to go. Step 1, collect your quadratic and linear terms on one side and move your constant to the other. Then we're going to find the value that completes the square. So I'm going to take my linear coefficient, negative 7. I'm going to do two things. Do you remember what two things? Divide by 2 and then square. Okay? Now, to square a fraction, we're going to square the top and square the bottom. Okay, that's my magic number. It's a fraction. Don't panic. It's going to be fine. So I'm going to follow the process. Add 49 over 4 to both sides. Remember, that's the number that completes the square. So I'm going to put it in a box to remind myself I've completed the square. And don't forget, add it to the right side as well. So we can see we've added 49 over 4 to both sides. Okay, once we have found that value, then our goal is to factor it. And you may be rusty on factoring and you think, how in the world am I going to factor with a fraction? No big deal. Remember, we made that a perfect square trinomial. So we know ahead of time it's going to be something squared, right? The first term in our binomial is the square root of the first term in our trinomial. And the constant in our binomial is the square root of 49 over 4. Square root of 49 is 7, and the square root of 4 is 2. And the sign always matches this first sign right here. And notice in the factor we have negative 7 over 2, and we saw that number over here as well. Okay? On the right side, we're going to add fractions. Let's do this as side work. So I'm going to evaluate negative 12 over 1 plus 49 over 4. Looks like we need a common denominator. So multiply the top and the bottom by 4, and we end up with 1/4. So combining like terms on the right side, we have 1/4. Now, if your brain is taxed from all of the algebra, remember you can check your calculations with your calculator as well. So I'm going to type in negative 12 plus 49 over 4 and turn that back into a fraction. 1/4. We did a good job. Okay, so completing the square is done. We will finish with the square root property. So I'm going to take the square root of both sides, and this leaves behind x minus 7 over 2 equals plus or minus 1/2. The square root of 1/4, we're just taking the square root of the top. Square root of 1 is 1, and the square root of the bottom. Square root of 4 is 2. We will finish by adding 7/2 to both sides. I'm going to sneak it in front of that plus or minus. And then let's go ahead and evaluate. One of our answers is 7/2 minus 1/2. The other one is 7/2 plus 1/2. 7/2 minus 1/2 is 6/2. 7/2 plus 1/2 is 8/2. So those reduce to 3 and 4. So our two solutions are 3 and 4. You can check that by substitution, but I also want to point out to you the original is also factorable. So notice if I go back to the original equation and I factor it, and set each factor equal to 0, I get the same two answers. Okay, so whereas we were able to solve this one both by factoring and completing the square, do notice that example B does not factor, so we were only able to solve that by completing the square. Okay, 3 methods down, 1 to go.